What does Newton's second law say about a mass on a spring with no friction? Well, to apply Newton's second law, it's important to understand the forces. So I'm going to draw an FBD for that mass on the spring there. There's going to be force of gravity and normal force. We'll take care of those. But those cancel out, so they're actually not very interesting. If the mass has a positive displacement to the right, then at that moment there would be a spring force pointing in the opposite direction because the spring would be stretched, and this would be the FBD I'd look at. If I write F equals ma, and then I'm going to analyze the x components. Well, something worth understanding about the spring force is that the formula we had for spring forces was given by Hooke's law. F is equal to kx. But if I think about this in terms of vectors, the spring force was generally in the opposite direction of the displacement vector. And what I said a moment ago is I was assuming that the mass was a little bit to the right, and at that moment in time, as it's going through its oscillation, the spring was stretched, and therefore the spring force was pointing to the left. Well, that's what that minus sign right there describes. That means if I'm going to use kx and I'm just looking at components, I should write minus kx is equal to positive ma, since the definition of acceleration is based on motion, which is positive when it's directed to the right. So that's the formula that I get based on F equals ma. Let's go ahead and check that answer. It actually checks out.